Metal manufacturing and machining powerfully combine precision and strength, using advanced heavy industrial machines to create durable, high-quality components shaping modern industries. The mobile raw iron logistics system in Brazil represents a groundbreaking solution for transporting hot metal efficiently from the blast furnace to the steel melt shop. At the core of this system is the multi-mover M700, designed for safe handling via remote control, ensuring both sensitive and secure movements with a maximum payload capacity of 700 tons of hot metal. Complementing this is the multi-mover Y550, which enables hot metal transport to both pig casting and deposit areas. Its high flexibility, space-saving concept, and independence from conventional rail systems significantly reduce investment and operational costs. For slag handling, the system integrates the Slag Taurus P120, featuring a maximum payload of 120 tons, excellent maneuverability, a protected support system, and an advanced dumping system with overload protection. Together, these innovations form a highly adaptable, cost-efficient, and safe logistics network for modern steel production. Open die forging with a hydraulic hammer, performed without a closed die, is an essential process in heavy industry. Instead of shaping metal within fixed molds, the workpiece is compressed between flat or simple tools, allowing gradual deformation into the desired dimensions. This method offers significant flexibility, making it ideal for producing large shafts, rolls, rings, and blocks. The hydraulic hammer provides controlled, high-energy blows that refine the grain structure, improve mechanical properties, and eliminate internal defects. Without the limitation of fixed dies, the process accommodates a wide variety of shapes and sizes, reduces tooling costs, and extends equipment life. As a result, open die forging ensures strong, reliable components for demanding applications such as power generation, shipbuilding, and heavy machinery. Progressive stamping is a manufacturing process where sheet metal undergoes blanking, forming, piercing, and flaring in sequential operations, producing precise parts efficiently. This method ensures high productivity, consistent quality, and cost-effective production of metal components. The process of dishing sheet metal begins by securing a forming tool in a vise. This tool, often taken from old machinery, has a hole in its center that prevents the sheet from flattening while being hammered. The metal plate is placed over this tool, which acts as a support, and the shaping is carried out with a rounding hammer. The rounded face of the hammer directs the force into the sheet, pushing the metal inward toward the hole. This action stretches the plate at the center, pulls the edges upward, and begins to curl the sheet into a shallow bowl shape.
If you see it start to do this, you want to kind of pound that downwards. If you're trying to make a bowl, if you do that, it might arc it the other way, and then you're just going to have a headache in your hand. And I'm very lazy. Oops.
Hammering is done gradually, not with heavy force, but with controlled, repeated strikes. The worker starts at the outer edges and slowly moves inward in circular passes. Each round of hammering sinks the center a little deeper, while the edges begin to rise, creating a balanced curvature. Because sheet metal can heat up quickly under repeated impacts, the workpiece is regularly cooled in water. This prevents it from becoming too hot to handle, protects the hands from accidental burns, and maintains the tool's condition.
And you don't have to rotating it, trying to get it into a full shape. Try it again, but just
As the shaping continues, adjustments are made whenever bulges or uneven spots appear. If the metal starts to wrinkle, lighter hammering is used to smooth it back into place, redirecting the flow of the material. The process resembles making a bowl, where consistency of curve is essential. Working in stages, the hammer circles become smaller and tighter as the center deepens. The 14-gauge steel, once heated slightly, becomes easier to move under the hammer and flows more smoothly. With this combination of moderate blows and occasional heating, the metal begins to take on a uniform dish.
like anything, you don't want the scale in there because you don't want to pound it into the steel, which leaves little black pit marks. If you want to go for a professional finish, you don't want that.
Throughout the process, care must be taken not to strike the support tool directly, since this can leave marks or damage both hammer and workpiece. Scaling is removed from the surface to avoid embedding impurities into the metal. By repeating the cycle of hammering, cooling, and reheating, the sheet gradually transforms from a flat plate into a deeply dished form.
He's dead joke, it's a Bohemian Rhapsody joke. That made myself sad.
Once a suitable depth is achieved, finer shaping begins. A small ball-peen hammer is sometimes used after heating the dish with a torch, helping to sink the metal further and refine the curves. At this stage, precision is emphasized, as the dish must match the contours required for helmet construction. When the shape is correct, excess material is trimmed so the edges will fit neatly against metal bands. These bands serve as structural supports for the helmet.
Actual bowls, serving plates, whatever. It's a good skill to have. And if you can't find a tool like this, or maybe it makes your life so much easier, because I can skip a lot of planishing. It saves so much time. And especially if you want to do this professionally, time is money. Smaller circles, try to get that.
Finally, the dished section is tack welded into position. The same process is repeated for additional pieces until all sections are formed and secured. The result is a set of concave plates that can be assembled into a strong and properly curved helmet.
Keep the scale out of it because it'll save a lot of time. The other reason not to mount one of these to a wooden post, all the scale falls through it. Sometimes catches itself on fire, which is, as much as I love fire, not a good surprise. Don't put your thumb up here. But it's getting there.
Patience and steady technique are the foundation of this method. By applying consistent hammering, controlled heating, and careful finishing, a flat sheet of steel can be successfully transformed into a durable dished component ready for assembly.
Over here, it
On trays,
I'll just heat it up with a map gas torch and try to sink it in with a little ball peen hammer. Just pound it this way a little bit. And then I just tack weld it in. Welding, I'm not about history.
rough machining of a cylindrical metal workpiece is an essential initial stage in metalworking, designed to remove excess material quickly and prepare the part for subsequent finishing operations. The process typically begins by securely mounting the cylindrical blank on a lathe or heavy-duty turning machine. Cutting tools with high durability are then applied to reduce the diameter, straighten the surface, and eliminate irregularities from casting or forging. In this stage, cutting depths and feed rates are intentionally high to maximize material removal efficiency. The surface quality at this point is secondary, as the main objective is shaping the workpiece close to its desired dimensions. Rough machining also helps reveal internal material defects early, ensuring that only sound pieces continue to finishing. By establishing a uniform, balanced geometry, this step provides the foundation for precision machining and accurate final tolerances The 4-axis rotary induction brazing machine is designed for efficient and precise joining of copper and brass components. This advanced system performs brazing by using induction heating, which ensures rapid, uniform heat transfer to the joints. The machine features an automated fixture that rotates smoothly, enabling the operator to process multiple parts on a single horizontal turntable. As each position is rotated into place, induction coils heat the components to the required temperature for brazing, resulting in strong and consistent joints. This design not only improves productivity, but also reduces manual handling, ensuring safety and repeatability. By combining controlled rotation with induction technology, the machine is ideal for producing high-quality copper and brass assemblies in medium to high-volume manufacturing, offering both efficiency and reliability in modern industrial applications. The process of using a brake lathe begins with proper measurement. First, the rotor must be checked with a micrometer to ensure it is still within serviceable specifications. If the measurements confirm it can be machined, the next step is preparation. The mounting hub must be completely clean of dirt, rust, and corrosion. Otherwise, the rotor will not sit evenly and the machining will be inaccurate. Safety precautions, including wearing safety glasses, are essential.
Here I've chosen this medium adapters. So we want to select the right size adapter that will fit inside. So first,
After cleaning, the correct adapters and centering cone are selected to mount the rotor. The inner adapter and a spring are placed first, followed by the centering cone, then the rotor.
followed by
Next comes the outer adapter, spacers if needed, and finally the hub nut.
by unwinding our feed counterclockwise. Once we've done that, we're now going to put on our outer mounting hub. At this point, if we put on our nut, it will not reach all the way. So what we do want to put on then is some spacers, dampen vibrations that will cause a poor finish. After that, I still need a little bit more of a spacer, so I can use any one of these components here as an adapter or a spacer to line thread. What's the purpose of the left-hand thread? So that it doesn't loosen off as we're machining the rotors. So as the friction increases here on our rotor surfaces, it will actually tighten up that nut. So that's in our favor. Remember again,
This nut has a left-hand thread, designed to tighten under machining forces. It must be secured with the proper wrench, ensuring stability.
and now we can line up our cutting head wherever we like. We want to try and get it centered. Once it's centered, snug it back up. Now, it doesn't need to be crazy tight, but it needs to be tight enough that it's not going to move on its own. So give it a good pull.
With the rotor mounted, the cutting heads are aligned to the center of the rotor. A vibration dampening spring is installed to minimize chatter. Before making any cut, a scratch test is performed. By lightly touching the cutting tips against the rotor surface, it is possible to check if the rotor is mounted correctly or if runout exists. If the scratch marks are inconsistent, the rotor is rechecked and remounted until aligned.
When I stop my, now at this point,
Once aligned, the cutting heads are
and I
zeroed
turn
and set for the
rotor
first pass.
180 degrees.
Machining begins with a rough cut, typically removing 6 to 10 thousandths of an inch, depending on rotor condition.
Make sure
The lathe feeds automatically outward, carefully removing rust, grooves, and irregularities. After the rough cut, the rotor should display a smooth, consistent surface. A finer cut follows, at a slower feed rate, removing 4 to 6 thousandths of an inch for a high-quality finish.
At this point, I can turn my rotor ever so slightly, and I'm going to start the lathe back up again, and I'm going to bring in both my cutting tips till they just touch the rotor.
Because a lathe produces a directional finish, which can cause brake pads to follow grooves and create noise or vibration, a non-directional finish must be applied. This is achieved by running the lathe in neutral and using sandpaper with oscillating motion across the rotor surface. This creates the characteristic swirl pattern of a new rotor, preventing pad chatter.
Be very careful.
When machining is complete, the rotor is removed.
for rotor.
All components, nut,
As you can see,
spacers,
the feed
dampener, and adapters are taken off in order and stored properly to maintain a clean, organized workspace.
will zoom in.
The rotor's surface is inspected by feel. It should be smooth, free of grooves, and visually uniform. Any greasy fingerprints must be cleaned to avoid pad contamination. If the rotor meets specification, it is ready to return to service with excellent braking performance.
It back in.
Finally, the machine and area should be cleaned. A tidy work environment ensures long tool life and reduces the risk of losing critical parts. Following these steps carefully guarantees safe, precise, and professional results when using a brake lathe.
Point we've finished our
The truck riveting process is an essential method for creating strong and durable joints in vehicle structures. Riveting can be carried out in two main ways: hot riveting and cold riveting. In hot riveting, heat is applied to soften the rivet, allowing it to be compressed easily and form the rivet head with relatively low pressure. This method produces smaller residual stresses in the rivet head, though thermal expansion and contraction may occasionally create internal gaps. On the other hand, cold riveting relies on high-pressure deformation of the rivet column. The cold flow of material eliminates gaps, generates higher stresses, and ensures a uniform and stronger joint. Regardless of the method, the quality of the joint depends greatly on controlling key parameters such as temperature, pressure, and time. Properly managed, this process guarantees safe, reliable, and durable truck assemblies. The Twin Power is an innovative grinding and polishing tool developed by DT, a renowned German manufacturer of high-quality abrasive solutions. Designed to meet the highest standards of safety, precision, and durability, this tool represents a significant advancement in surface finishing technology. One of its key innovations is the simplified disc mounting system, which eliminates the need for traditional backing pads. This user-friendly feature reduces setup time and ensures secure operation. In addition, the Twin Power is equipped with 3 integrated viewing and cooling windows. These not only provide clear visibility of the workpiece, but also maintain precise control during grinding or polishing, even under challenging conditions. The tool excels in applications such as accurate chamfering and versatile surface grinding. Its robust construction guarantees a long service life while delivering impressive grinding performance. Enhanced airflow prevents excessive heat buildup, minimizing the risk of unwanted discoloration or damage to sensitive materials. Comfort and control are central to the design. Operators benefit from excellent ergonomics, stable handling, and reliable performance, which allow for consistent and high-quality results. Safety remains a top priority, with the thin yet durable structure of the tool ensuring secure operation, even in tight spaces. With Twin Power, users gain a combination of precision, efficiency, and safety, making it an ideal solution for professionals who demand uncompromising quality in grinding and polishing tasks. The tube preparation workshop plays a central role for products involving metal tubing. Heavy-duty automated cutting machines ensure that tubes are cut to exact lengths with finished ends, ready for subsequent operations. When extreme accuracy is needed, tube laser cutting technology is applied, delivering perfectly prepared fittings that simplify the welding stage. Tube bending is then carried out using a 9-axis electrical bending machine, capable not only of bending with accuracy, but also of marking the tubes during processing. For flat materials, the laser cutting workshop provides precision even on delicate and fragile surfaces, such as mirror, satin, or brushed finishes. Larger and heavier steel components are processed in the steel plate workshop, which is equipped with several bending and rolling machines able to handle complex forms. The welding workshop, certified by third parties under American and European standards, ensures structural integrity through skilled workmanship. Additional machining operations, such as turning, drilling, and cutting, are completed in the machining workshop, where lathes and specialized equipment guarantee exact tolerances. Surface quality is then refined through chemical treatment workshops offering immersion and in-house water treatment. Followed by polishing workshops providing both mechanical polishing and tribo finishing for small parts. Finally, every component undergoes strict quality control before packaging. With reliable on-time delivery and professional shipping services, Yoltech consistently delivers aluminum and stainless steel assemblies that combine precision, durability, and a superior finish. The production of double walls and floor slabs in modern precast plants has reached a level of automation that ensures accuracy, efficiency, and consistent quality. The process is carried out on large circulating pallets, which move automatically through a series of workstations. The process begins with cleaning profiles and the application of separating agents. A fully automatic shuttering cleaner is employed to ensure that all shuttering profiles are free of residues from previous casting cycles. At the same time, a separating agent is evenly applied to prevent adhesion of concrete to the shuttering surfaces. This guarantees smooth demolding and prolongs the life of the equipment. Next, the pallet cleaning and separating process takes place. Using a fully automatic system, pallets are cleaned thoroughly, and a thin film of separating agent is applied in a single continuous operation. This automated step is critical, as it ensures optimal surface quality of the final elements and reduces manual labor. Following this, contour plotting is executed under fully automatic CAD/CAM control. The system transfers the digital building design directly to the pallet surface, marking precise contours and dimensions for shuttering placement. This not only eliminates human errors, but also accelerates the setup process. Once contours are plotted, profiles and inserted parts such as electrical conduits or sockets are positioned with absolute precision and at high speed by robotic handling devices. Supplementary parts that cannot be fully automated are placed manually at a dedicated workplace system, ensuring both flexibility and accuracy. The pallet transport system relies on frequency-controlled cross-lifting cars, which move pallets transversely between workstations. This guarantees smooth and efficient circulation of materials throughout the plant. Reinforcement preparation is a crucial step in the process. Robotic technology is used to place reinforcement meshes or cages on the pallets. In areas where complex geometries are required, workers manually complete reinforcement placement while also carrying out quality control checks to verify compliance with design specifications. After reinforcement is secured, automated concreting begins. The prepared pallets are filled with concrete through a fully automatic concreting device. Concrete is evenly distributed, followed by vibration and compaction to remove air voids and ensure strength. The pallets then proceed to the storage and curing chamber, a highly automated system equipped with heated racks. Here, the concrete elements cure under controlled temperature and humidity, accelerating hardening and ensuring uniform quality. A pallet storage and retrieval machine manages the flow of pallets into and out of the curing chamber. For optimized workflows, a pallet overtaking station is used, allowing production sequences to remain continuous and efficient. Once the curing stage is complete, double wall production continues with pallet transferred to the turning area. An overhead pallet turning device is employed to rotate the first concrete shell and place it onto the second shell, forming a double wall. This step combines precision handling with safety, avoiding damage to the fresh concrete surface. After assembly, the finished floor slabs or double walls are transported to the loading area. Here, a tilting station with an adjustable support beam carefully positions the elements for loading. A mobile lifting platform ensures that heavy double walls can be handled safely and efficiently by workers. Zheyu Heavy Industry Science and Technology, established in 2014, is a professional manufacturer specializing in research, development, production, sales, and service of concrete mixing equipment. Our product line includes concrete batching plants, concrete mixers, mobile batching plants, stabilized soil mixing plants, screw conveyors, bolted cement silos, cement feeders, and cement bag removers. With over 16 years of industry experience, our technical team ensures high-quality standards supported by advanced equipment such as cutting, welding, milling, and grinding machines. Certified under Quality, Environment, and Occupational Health Management Systems and CE standards, our products are trusted across China and exported to Russia, Mongolia, the Philippines, Indonesia, Kazakhstan, Uzbekistan, and Oman, while also offering OEM and ODM solutions.